All right. Good morning, good afternoon, wherever you're joining us from today. Welcome to day 4 of the New York Oracle User Group Virtual Lunch Hour Training Days Conference. Today's focus is on PL SQL with sessions by Ask Tom's Chris Saxon and Oracle's Jeff Smith. Hopefully you are familiar with these fabulous speakers. We're so lucky to have them here today for the New York Oracle Users Group. A little bit about NYOUG. It was founded in 1984 for the exchange of ideas, assistance, and support among users of Oracle software products. The organization consists solely of volunteer users, consultants, and vendors of Oracle-related products and services. You can sign up for a free membership, or you can even have paid membership plans with more perks. Visit nyoug.org for more information there. As a member, even a free member, you can actually rewatch tons of webinars like this on demand and see slide decks as well. This week's conference is sponsored by Viscosity, Quest Software, and Incorda. My name is Monica Lee, and I am the marketing director for Viscosity North America. Oh, I'm sorry, here. If you want to follow NYOUG online, please do at Twitter, Meetup, LinkedIn, Facebook, or their website. All right, so Viscosity is a full Oracle stack consulting firm with core expertise in Oracle database, including RAC, Oracle Apex. We do zero downtime migrations, performance tuning, high availability. We've got decades of experience with infrastructure, including engineered systems. And lately, we've been upgrading all of our customers to Oracle Database 19c. So if that's on your to-do list, reach out. We also host monthly workshops and webinars through orapub.com. The folks you see here on the screen are some of my amazing colleagues and regular speakers on Oracle technology. Hopefully you are familiar with some of them. So as of January 1st, orapub.com is powered by Viscosity. Orapub was founded by Oracle ACE director Craig Shalahammer, and he's now part of our team. So we're super thankful for that. And we've got tons of resources for you guys here at orapub.com. Similar to nyoug.org, we've got our own database of tons of workshops, webinars, how-tos, resources you can download, things like that. Then there are bigger, heftier workshops you can join for a fee or for paid members. So check that out. Today's webinar is live and it is being recorded. You can find them later at orapub.com and at nyoug.org. All right, so you are hopefully familiar with Quest software. They've got products such as Toad, Foglight, and SharePlex. We'll hear more from them between our 2 sessions today. But first, I'd like to introduce you to Incorda, our other sponsor. Ryan is here to tell us a little bit about Incorda.
Awesome, team. Hey, so Ryan Garrett here. I'm a sales engineering team lead here at Incorda. Great to be with you all again today. I know at least some of you have seen me before earlier in the week, and my colleague Patrick Rafferty in the last couple of days. As mentioned, I am from Incorda, and what I'll do is I'm just going to give you like kind of a 2-minute overview of Incorda, and then I'll do a little just kind of a quick click through just so you can kind of see where it is. And then I've also put my contact information on the screen here, and be more than happy to continue the conversation here. I'll pause for a few minutes at the end for questions. And then if you want to have additional conversations, please reach out to me. More than happy to have a conversation and continue with the good evolution of Incorda. So really quickly, really what Incorda is purpose-built for is simplifying analytics and really being able to deliver valuable business consumable data with reducing the time, money, and engineering effort in order to achieve that. Many of our founders came from Oracle. They came with really the express purpose of creating a company about simplifying analytics from Oracle, and we've since expanded out to other data sources as well. But for the conversation today, we'll focus really on Oracle and some of the value that we bring by simplifying that process. And if you think about the traditional process, you're going to go through, from Oracle, you're going to go through to an ETL tool. You're going to do some manual work to that. You're going to write some code. You're going to write a bunch of SQL queries, really to kind of get data that's consumable and ready for the business. Within Corda, the whole idea there is we can shorten that process, reduce the time it takes for you to actually deliver business consumable data, reduce the amount of code that you have to write, as well as, I know there's a lot of SQL experts on here, is, reduce the kind of the burden on kind of manually writing SQL queries and manual kind of creating views and marts and all those things, and giving you a single platform streamlined that's a no code, low code environment in order to deliver business consumable data. And if you so choose, if you want to go write your own SQL queries and include those into Corda, we're happy to accommodate that as well. But really the idea there is to give you that platform that makes accessing and getting data consumable ready by the business as flexible as possible. So what I was thinking I would do is just kind of take a moment and talk a little bit about, how we do that. So one of the key things that Encorda does in this kind of lovely kind of blue center here is we have the concept of blueprints. Blueprints are, business applications that are tailored to specific modules within Oracle. So think of accounts receivable, accounts payable, general ledger. So what Encorda has done is we've used our engineering efforts to go map those out, to go figure out how we get kind of usable data out of that. And then we've packaged that up as a blueprint. And I'll show you here just kind of what we're talking about is some of the blueprints. We have quite an extensive list across the Oracle suite, as I mentioned, order to cash, procure to pay, order management, general ledger, et cetera, et cetera. Really any of the modules that you're going to see within Oracle, we've gone ahead and mapped those out and created a blueprint for you. And so what do we mean by a blueprint? Well, I guess let me show you is probably the best way. But high level, the joins, the mapping, the metadata mapping between tables. So you don't have to kind of go in and kind of write a bunch of SQL queries and trying to figure out how things work. So we've kind of figured that out for you. That's the first piece. The second piece is a physical schema, kind of, again, linking tables together. The third piece is a business schema, and I'll show you these very quickly. And then the last piece is we do have kind of out-of-the-box reporting that many of our customers take advantage of and or will snap into an existing framework if you, leveraging Tableau or Power BI or whatever you to visualize. We're happy to kind of meet you there as well. So let me just show you really quickly. So what do we mean? So this is an account. This is Oracle EBS. This is an accounts receivable. This is part of what, when we deploy a blueprint, we're actually going to deploy this ERD, the relationship diagram here. So you can actually see out of the box, we're going to actually deploy this. We're going to do all that join work for you. We're going to figure out how those tables map to each other, how do accounts match to other issues, have common fields across all of those. So we're going to really simplify that entire process of you getting data and getting accessible within the platform. And then we're going to give you that platform. So if you need to join in custom tables, maybe that we haven't grabbed as part of our blueprint, or any of the custom workflows that you're able to do, we're able to do that within the platform here as well to extend this ERD to bring it into what is, how you're deploying it within your environment. That's the physical layer. We also deliver that business schema layer, and I'll show you here what we're talking about here. Again, here's an accounts receivable one, so you can actually see, simplify this, get this nice, friendly, consumable by the business, so your business team can then drag this onto a canvas. Nice, friendly names, things that have been pre-joined, reduce that complexity significantly. And then the last piece is actually, as I said, kind of some of the out-of-the-box reporting. And I'll show you just kind of high level here what this goes across, financial, supply chains, value chain, etc. I'll just drill into the financials here, and we'll take a look at the accounts receivable. And we'll specifically look at one of the ones that we have, which is the accounts receivable summary. And so we're actually creating out of the box, this is an example of an accounts receivable summary. But out of the box, we deploy these as part of our blueprints, hand these over to our customers. So we really shorten the time it takes to A, get data up and running, and B, then give you that flexible platform, because what we hear almost from always from all of our customers, that it's really difficult, to try and get reporting, and that it's really inflexible. And so Encorta is going to give you that platform there to make it nice and flexible. So if somebody needs to add a column, add a field, add a calculated field, add a new data source, they can bring that all into Encorta without writing a whole bunch of code, and without trying to do a whole bunch of SQL queries. And we can give them operational data and pre-built reporting out of the box on very short order. So let me pause there for a second, folks, and see if there's any questions. And then what I'll do is, just while I'm doing that, I'll kind of put my screen back up here with my contact information, and happy to continue the conversation as well.
Thank you so much, Ryan. And as you guys maybe think of some questions for Ryan, I'm just going to remind you all, today's sessions are live. That means you should definitely ask questions. You've got great speakers today, great sponsors. If you can, please submit them in the Q&A box versus the chat box. If you have any logistical questions or issues about the webinar or about anything, you can throw those in the chat. Otherwise, if you're asking something to a speaker, throw it in the Q&A, please. Also, presenters today will address your questions as they can. If they run out of time, if they're at least in the Q&A box, they can respond to you after the fact via like chatting back to you in the Q&A box. So definitely remember that. And if there's no time for that either, I'll do the best I can to get you in touch with the speakers and see if we can get your answers. Otherwise, I think we're ready to go. Yes, today's session is being recorded. You'll get a link to that. Yes, you'll get slide text for it. We'll send that to you as well. I think everything today should be in your inbox sometime on Monday. So without further ado, Chris, it is all yours.
All right, great. Thank you. All right, then. So we'll start with a situation which I think most, if not all of us, have encountered one way or another. You're buying something on your phone or on the internet, and you click the hit buy button, and suddenly the app takes forever, and it just sits there, and you wait and you wait, and you think, is this actually gone through? Is it going to work? What's going on? And this is quite, can be quite concerning as a consumer. Is the payment working, that kind of thing. But internally, if you're the developer or support staff for this, there's kind of an equally fraught thing. It's like, why is it slow? Why is it taking so long? And many of you have probably may have experienced this internally, the kind of internal battle that goes on between developers and DBAs over where the actual performance problem lies. And developers will often kind of go, the SQL's really slow. It's taking forever to run. What's going on here? And the thing is, when we're doing something like placing an order, quite often that will generate a whole bunch of inserts. There's lots of tables we've got to add rows to, and all the products that we're going to purchase. And the DBA is looking at this, or back-end developer, and all you can see is a bunch of insert with values statements which execute super quick, and you're just like, everything's fast. I can't, I can't help you here. What's going on? So this, classic battle that goes on, and there's lots of reasons that this could occur, but a common one is something like this. We've got some application code. It's a Java example here, but it really could be any kind of mid-tier language. Essentially, the customer is buying a set of products. So we've got an array of the things that they've got in their basket, and we're looping through them and running an insert on the database for each one of these. So what this means is we end up doing a lot of backwards and forwards from the application to the database. Do an insert, get the result back. Do an insert, check it worked, so on and so forth. And overall, this process can take a long time. But as I said, if you just do single row inserts, they're really quick, and there's pretty much nothing you can do to make them faster, or certainly your tuning options are very, very limited. And so what's the real problem here? Well, it's all the network time. So typically, the network is the slowest component in your architecture, often by orders of magnitude, right? So the more time we spend on chatty processes like this, going backwards and forwards from the application to the database, the slower overall, the slower process is going to be. And we're not really doing useful work here. So ideally, we want to eliminate this, or eliminate it as much as possible. we've still got to make a call to the database. How can we do that? Well, a great way is to use PL/SQL. If we do that, if we create a store procedure, then we can send all the information to the database in one call, and that will send back its response. Now, this might make the process of calling the database slower. That process takes longer to run inside the database, but now it more closely matches what's actually happening in the application. So the front-end developer goes, this process takes a long time. It's running slow in the database, and you're looking at back-end metrics for it. You'll see a more similar picture, and you can come to a more common understanding and figure out what really is actually going on here. So if we've got this process and we've taken it and created our PL/SQL procedure, we've probably got something, create an order, and as I say, we'll accept an array of the products that people are purchasing along with various other details they might have done. And in there, we might have done something similar to like what we did in the Java code, essentially just loop through all the products in that array, and then maybe we'll have some logging, but also insert into the database. So it seems good, right? As I said, we're eliminating the network here. So we've saved ourselves all that back and forth round trip. But there's still a couple of problems that might occur here. First, we might run into some runtime errors. Specifically, we are assuming that there are no gaps in this array. It's indexed at first entry is index 1, and then 2, 3, 4, 5, up to however many elements there are in the array. If there's any gaps, we can run into a problem here. But secondly, we're still just executing one row on each iteration of the loop. Now, just doing this on its own should be a substantial performance improvement over calling it from the application, because as I said, we're removing the network, but we're still just inserting one row at a time. This really doesn't make the best use of SQL. So what I'm going to do is look at some of the things we can do in PL/SQL to address this. And particularly, we'll look at some of the cool stuff that's here in 21C to make working with loops an awful lot easier. So, hi everyone, I'm Chris Saxon. I'm part of Gerald Wenzel's developer advocate team and the answer team on Ask Tom. I'm here to help you get the best out of Oracle SQL and PL/SQL, and hopefully have some fun whilst doing so. So with that in mind, let's dive in and look at some of the cool stuff we can do. As I said, we'll start off, and actually I was talking about all that order problems. I'll discuss a little something different to start off with. So this is the kind of thing you might have been asked in an interview or some other kind of like online quiz. You've been asked to write a program which displays the multiples of 3 and 5. Well, there's a variation on the FizzBuzz problem. Loop through some numbers, and if it's a multiple of 3, input, output fizz. If it's a multiple of 5, output buzz. If it's a multiple of both, print FizzBuzz. In this case, we'll simplify it slightly and say we only want to output the values that are a multiple of 3 and 5. So 15, 30, 45, so on and so forth. So we're going to write this with PL/SQL. You'd have to do something like this. We'll loop through from 1 up to however many values we're going to consider and check if that value is a multiple of 15 or 3 and 5. So this works, fairly straightforward, fairly easy to do, but there's a potential issue here, and that is we are considering every single value in the range. We start at 1 and keep going and check every value, run this if test against it. And if we only want to display the numbers that are multiples of 15, we are, checking 14 times as many values. 14 values we don't need and only 1 that we actually do need. And there really wasn't a way to avoid this previously with PL/SQL. Now, for something simple like this and fairly trivial, this probably isn't an issue. It's always going to execute so fast that you're never really going to notice any difference here. But let's imagine actually inside this loop, we're doing something a bit more complicated. If it's a multiple of 15, we're going to run some SQL or whatever. There's some more interesting things going on here. So, like I say, as it the key thing is it works, but we are considering lots of values, looping through lots of values we don't even care about. We're never going to actually process. So we've addressed this in 21C. There's a lot of enhancements to loop controls we've got in 21C to make working with these easier to do, but also to avoid problems like this. So to start off with, there is this new stepped operator. So we've got this by syntax. Now, rather than by incrementing by 1 each time, so we go 1, 2, 3, 4, 5, we increment by whatever that expression is. So 3 times 5, 15, we go up in multiples and 15. First is value 15, then we jump straight to 30, then we go to 45, and so on and so forth. So we're bypassing those other values we don't need, 1 to 14, which we're never going to consider altogether. Let's say, and for something trivial like this, you're really not going to notice the difference. But if we're doing something more complicated, more CPU intensive, it's possible this could give a noticeable boost in performance. So this helps us if we're doing, like, as I say, kind of FizzBuzz style challenge where we have a fixed increment. Let's imagine you're in this interview and they're throwing these stupid coding challenges at you just to kind of break you down and figure out, make you cry about how much you don't know about programming, that kind of thing. So they've done the FizzBuzz one, and they say, all right, now we want you to display powers of 2 less than 100. So we'll start at 1 and display all the powers. So 2, 1, 2, 4, 8, 16, so on and so forth. Now, first thing you might try is use this stepped increment again, multiply by 2 each time. But we can't do this now. We can't use this by syntax for it because that value has to be a fixed offset each time. We can use an expression to define it, 3 times 5, but the result of that has to be the same on each iteration of the loop. When we're doubling the step each time. We start, the gap is 1, then it goes to 2, then it goes to 4, so on and so forth. So rather than trying to step over things like this, what we can do is something like this. We can have a control to state whether or not we actually enter the loop. So this bit and is a little sneaky trick to check whether something's a multiple of 2. But the key thing here is we only execute the loop when that is true. So basically, we start with 1, check if that is true, and then jump inside the loop and actually execute it. And so we still iterate through every value, but we only enter the loop when that condition is actually true. So as I said, this is something that might help if we're doing something expensive inside this loop. Let's say running a whole bunch of some complicated slow running SQL, for example. But again, for something like this, some pretty basic maths operations, you're not going to notice the difference here. So we're still processing every value. And in many ways, what I've done here is essentially kind of taken the if condition out of the body of the loop and put it into the loop itself. So, it's a nice thing to do. I think it's a better, cleaner way of expressing what your intent here. It says, only execute what's inside here if these criteria is true, rather than doing a loop and straightforward having an if, straight away having an if. But generally, it probably doesn't save us very much here, at least in this example. So fortunately, there's a couple of other tricks. So we can actually double the index every single time, okay? So the first of these is a repeated expression. Ooh, okay, repeat. So what we're doing by saying repeat is keep doing this. On each new iteration of the loop, run that expression. So in this case, doubling by 2. So we start off with first entry is 1. That's our first value in the loop. We'll execute that, come around and repeat that expression. Powers times 2, index times 2. So we'll go to 2, then we'll go to 4, then we'll go to 8, so on and so forth. And key thing here is we keep doing that until that while condition is false. Now, what to be aware here, you don't strictly have to supply that while condition, as in the code will compile. It will actually start executing it if you ignore that while condition. But if, depending on what your expression here is, you could actually get stuck in an infinite loop. So, make sure you got the termination condition here, either in the while here or in the loop itself. So this is a neat way of actually doing this. We can define this repeated expression and keep going until we hit our value of 100. So this is probably the better way of doing this. There is another more interesting way of doing this. We now have the ability to define mutable index variables. That is, variables you can change their value within the loop. Okay, so you see I've got powers declared it as mutable. That means as I execute inside that loop, I can assign it a new value. As you can see here, within that loop, I am doubling it each time. Now, those of you who are paying attention and looking very closely are thinking, are probably looking at this and going, hang on, you're doubling it and then subtracting one. Why are you doing that? Well, even though we're actually changing its value inside the loop, when it comes back around to start the next iteration of the loop, it still adds one. It still increments the value for that loop. Interesting. Okay, so a couple of things to be aware of here. Mutable variable, iterans sound great, but they are a fantastic way to end up with infinite loops or other sorts of unwanted, unexpected behavior. Really, I feel not great about really talking about this. I know someone out there is going to get themselves in a big horrible mess trying to play with these. You really should avoid these and only use them if there's genuinely no other way of actually doing this. But it is a neat, useful extension to the language, so you can have these mutable variables to manipulate them inside the loop. Okay, so we looked at a few things there. Actually, we saw we can have a stepped expression, change what our increment is each time, have a condition to say whether or not we actually enter the loop body. We can do repeated expressions, declare the variables as mutable, and so on. So that's all nice, and as I say, can help solve those interview style programming challenges you might be assigned. But how does this help us with the problem we were talking about at the start, right? I was talking about we're creating an order, you're receiving an array of products, and we want to loop through them or iterate through them to log them and save them into a table. So we had some code that did something like this. So just to kind of reiterate one of the points here. When you've got a loop like this, you're starting at 1, going up to the count, you're assuming that every value exists from 1 up to the count. So the array indices are 1, 2, 3, 4, 5, etc., up to however big it is. If there are any gaps inside that array, you're going to run into a no data found error somewhere in this code when you actually try and process it. So this only works with densely packed arrays. How do we get around this? How do we solve this? Well, previously, it was all a bit of a pain. It was a bit of a faff. You'd have to do a while loop, something like this, which, okay, it's not too complicated, but it's quite a lot of code. It is a bit clunky, and it's quite easy to get wrong. For example, forget to assign the next value and end up with an infinite loop or something daft like that. So while this is doable, it is a bit messy, right? It would be nice if we could just say loop through the values inside the array and use the actual indices of the array to drive the loop. Good thing is now in 21C, we can actually do this. So we've got this indices of syntax. Those of you who've worked with for all will probably have seen this, be familiar with this. Use the indices for that products array to actually drive the values for the loop. So as I say, the array drives the loop here. This gives a couple of big advantages, in my opinion. First up, I think it more accurately explains what you're trying to do. It makes the code a bit more self-documenting. You are iterating through this array using the values that actually, the elements that actually exist. But more importantly, because if there's gaps, we're just going to skip over them. We're using the actual index values. We're not going to run into those no data found problems, and which is generally the kind of thing you want to do. You don't want to have to code. Usually that's a problem and you want to avoid it. So that is a nice, really good enhancement, I think. Something that I've started using a lot, playing around with 21C, and find it really hard to go back to the old ways of iterating through loops. So that helps with our kind of runtime error type problem we might have had before. But as I said, we still also have a problem with this insert. Essentially, we just kind of took that Java code and just pasted it straight into PL SQL with the appropriate syntax changes. So we're still executing that insert once for every iteration of the loop. Now, while, as I said, this is significantly or should be significantly faster than going across the network, we can still do a lot better. Why? Well, the SQL and PL SQL languages have separate runtime engines. Every time PL SQL calls SQL and the opposite, there's a context switch between them. And if we do that lots of times, that can really start to add up and make our processes quite a bit slower. So rather than have that insert inside the loop here, what we really want to do is, as I was kind of mentioning earlier, have a for all statement. So even though it's got the word for and for all in there, that is not a loop. What it actually does is passes all the elements of the array, or the indices of the array, I should say here, to the SQL engine in one call to the SQL engine. So we avoid all that context switching, which certainly if you're inserting large arrays can lead to good performance gains. So we've got some good improvements here. We've got some better way to kind of iterate through for things like logging, and we can use our for all syntax to improve the performance of the actual inserts as well. Now, as I said, this helps inserting into one table. And as I said, when you're creating an order, not only hopefully, or depending on your business, potentially inserting lots of different products, there's a good chance you're inserting to lots of different tables as well. There's the order header, the order items, where the actual products are going to go. You might update the customer records, you might issue some invoices, insert to the invoice items as well, maybe create some shipment things, and so on and so forth. And certainly for those invoices, you've got the invoice header and we've got the items for each product. So chances are we might have two of these for all statements, one for the order, one for the invoice, and have both of those inside this procedure. Or maybe there might be separate procedures, but we'll combine them together in one call to the database. So by doing this, as I said, we avoid the loops, we avoid those context switches, and we can make these processes an awful lot faster. Yes, okay. All right, well, yeah, I think a lot of people are making it back. I'll keep going. Hopefully anyone else who got lost there made it back. Oh, a bit of live adventures there, okay. All right, so what I was saying, yes, we could be inserting to multiple tables, and we've got two tables, orders and order item, invoices and orders, where we're inserting these arrays of products. Now, an interesting question might occur is like, well, what happens if there's an error process running the actual insert? We get unique constraint error or something like that. We'd like now maybe to actually keep processing the entire array and skip over some of those types of errors. And we can do that with this save exceptions clause. So what this does is it says, if in that batch of inserts that we're running, there's an error in any of them, basically just ignore it until we've processed the whole array and then raise the exception at the end. So this way we can go through the whole array and actually capture the error failure details afterwards. So we've inserted some of the details, but not necessarily all of them. Whether this is actually a good idea for something like creating an order, do we want to insert some of the products but not all of them into the order? Okay, that's a conversation for another day. Let's just assume that we actually need to or want to do this in this situation. So we're capturing these exceptions, and as I say, we will still actually get an error, and we'll need to trap it, and then we can loop through and find what all the errors are. So failure and for all is not actually it's not an inbuilt error. It's just one I've said here just to make things a bit clearer. but we're going to iterate through those array exceptions and then build up an array of what the problems are. So we can do this to keep going past errors. So as I said, we want to create our error array here. And that leads on to another kind of interesting question. It's like, well, what about initializing arrays? I've said there's lots of stuff we can do to improve loops. What about managing arrays too? Well, this again was something which could be quite clunky in previous versions of Oracle database. Now, if we go back to our FizzBuzz style example, we can do something like this. If we want to load an array with the values, the multiples of 15, so 15, 30, etc., we can iterate through them and on each one add a new element to the array. So we can use the 21C syntax here to do that, or we could just do an if statement as we would before in previous versions. Or maybe if we want to do it with SQL, you could do something like this. We could do bulk collection, where we load values from a table into our array. Bulk collection is probably the more general example of this. You know, it's not that often we just load an array with particular numbers. So we can do this, but and in both cases, there's something we can improve this. So in 21C, we introduced, or 18C actually, I should say, we introduced the concept of qualified expressions, which you can also refer to as type constructors. So from 18C, PL/SQL record types and associative arrays all now have essentially an implicit constructor associated with them. So you can initialize them in one statement. So for arrays, you could do something like this. We got our DBMS SQL number table array. We can initialize it by passing in all values here. And this works because this type is the implicit constructor. You know, we don't need to do anything special now. This is just syntax of the language for how it works. And this actually works really well with records, right? Where previously, before you'd had to have a whole bunch of statements, you can now just initialize the whole record in one go, or the attributes of the record as needed. But it's still quite a faff with these arrays, right? Notice I'm having to explicitly list out what all the values are, which is probably not what someone's looking for if this is a programming challenge. You know, it's some kind of interview. They're asking you to write some code to do this. They don't want you to just like list out the values 15, 30, 40. They want to have some kind of control loop or something like that, right? So this kind of works, but only in limited situations. Maybe things like test scripts, data generation, where you know exactly what you need to initialize the array to. In the real world, that's fairly unusual. Now, the nice thing in 21C is we've extended this further, and you can essentially put a loop to initialize these values inside this constructor. So you can do something like this. We're just going to iterate from the values, the multiples of 15, so from 15 up to the limit, increasing in steps of 15, generate those values. So this will give us 15, 30, 45, etc., and it will enter those values. So n is the iterator here. Those will be the values in the array. We've got this sequence keyword because that controls what the indices are. So it starts at 1, first element in the array is 1, then 2, so the consecutive as before. So that's what sequence does here. But you can also specify a custom index. We can use the index keyword or clause as well, and we can have an expression to define what they are. Here I'm just saying the index values are the iterator values. So previously, the element 1 was the first element and its value was 15. The second element was number 2 and its value was 30. Now we're saying that number is the index. So the first element is number 15 and its value is 15. So it's 15 goes 15, 30 goes 30, 40 goes 45 goes 45, and so on and so forth. So it was pretty cute, pretty cool, pretty neat. But as I said, this is useful for maybe these kind of interview style programming challenges But when would we really do this? It's not that often, at least in my experience, in real world code, that you would actually initialize an array doing something like this, just numeric values. It's much more common that you will initialize an array using some SQL. We'll use bulk collect to load the values into the array from some database table here. So again, this works well if we just want densely packed starting at 1. But what if we want a custom index for the array? In particular, what if we want to use a column from this query as the index values? So as we had an example just before, the first element is actually number 15, which has the value 15. Second is number 30, and so on and so forth. Well, one of the really cool things is we can now use cursor for loops to initialize these arrays. Ooh, cool. So we've got our array, we can declare our cursor, which is getting whatever it is, and then do something like this. Looks basically like a cursor for loop, except we haven't got the loop keyword there. And we're saying indexed by this F and N, losing the ability to speak here, the column from that query. We're using that as the actual indices for the array we are populating. Ooh, really neat. Okay, neat, but I'm sure some of you are watching this and going, well, okay, still why I still don't see the point here. I still not entirely sure why I would be doing this. What's going on here? What's the point? Well, you've almost certainly in your application got a whole stack of lookup tables, and some common ones include things like countries and currencies. You might not have exactly these ones, but you've almost certainly got something like these. And particularly for countries and currencies, good chance you use the ISO codes. So for currencies like USD, GBP, EUR, that kind of thing, could be the primary key of the table. If not, it almost certainly should be a unique key in that table. And you might want to load an array of currencies or countries or whatever, and actually use those ISO codes as the indices. So we're indexing by varchar 2. Really neat thing about these, using these improved qualified expressions, we can actually use that cursor for loop with that column as the index to initialize the array. So here now the actual indices are those currency codes, USD, GBP, EUR, whatever other currencies they actually use. So you can reference the entries doing something like this. Really neat. I think this is something that is really, really tricky to do before with PL SQL. If you wanted to have an index by varchar 2 array and populate it from a column in a table, you have to first bulk collect it or do a cursor for loop and then rearrange things. It was all a bit of a mess. This greatly simplifies things and makes it much easier to do. Okay, so cool. That gives us some better ways to initialize these arrays. How does that help us when it comes to managing these errors? Let's go back here. We've got our save exceptions. So potentially we're building up our arrays of orders. So what we want to do is, first up, we want to, if there's errors in the orders, build an array of the order errors. Then for the invoices, build an array for those ones. Finally, we might want a consolidated array of all the errors, all the products that have errored in either table. Combine them into one array, right? Merge the two arrays together. So we'll start off with these two first things. The code to do them is basically the same. We'll just load them into different arrays. So we've got our order errors, and we can use our qualified expressions, array constructors, to initialize them based on however many values there are actually errors there were in an array. Now, for the really cool part, we can then combine the two arrays doing something just like this. So, whoa, cool. We're just going to iterate through the values within each of these arrays and merge them into one array containing all the errors. And we can do this all in one statement. So this is something, again, something you could do before in PL SQL, but potentially there was quite a lot of code to do this. So, and at this point, some of you are probably scratching your head a bit, just going, well, what's going on here? How does this all work? So I'm going to jump over to a demo and kind of walk through these so you can see them for real, and we can discuss a bit more about them. If there's any questions or comments on these at the moment, please put them in the Q&A. Please put them in the QA. I see there's a couple of things come into the chat. It's easier if they go in the QA. It just makes it a whole bunch easier to manage. See this question about, can we use insert all? I'm not sure what you're asking there exactly. If you could give a bit more of a fleshed out example. I think you're saying insert all to insert into multiple tables with for all. I'd have to check, to be honest. I can't remember off the top of my head. I think so, but I would have to check. Let's see. So at this point, I'm gonna move over to a demo. And if you've got questions, start putting them in, and I will address them as we kind of work our way through this. So first up, I'll use those new by and when syntax. So let's run that. We'll do our FizzBuzz style challenge, output the multiples of 3 and 5. So everything that's a multiple of 15, essentially there. Now I split this into 2, by and mod, just to kind of show that they work separately. You know, two for one demo, right? In reality, you would almost certainly do like FizzBuzz like that, combine those together. But just to show, you know, if I change these values, things that are multiples of 2 and 7, so 14, we can change those, and now we're getting the multiples of 14 in the input. So we can use these to control what our increment is and whether or not we actually enter the loop. So that's kind of neat. Let's move on to that next challenge, powers of 2, right? And as I said, we'd want to do this with a repeated expression. So here again, I'm just using some variables to make it clear what's going on. We're showing all the powers of 2 that are less than the upper bound, 100. So 1 to 100. So 2, 4, 8, 16, 32, 64. And because the key thing here is each iteration, we are doubling the value we are incrementing by. So instead of processing all 100 values or numbers between 1 and 100, we only actually execute the 7, which are powers of 2. And again, you know, if I just change that to 3, so we get all the powers of 3, like 3, 9, 27, and so on, we can do that as well. Some really cool, really neat things we can do here. Finally, on these kind of new things, the mutable thing, where we can actually change the value inside the loop. So we'll do that. And this is the same as I had previously, powers of 2. We are multiplying up by 2. As I said, you do need to subtract 1, because what we're doing here is we're saying multiply it by 2, and then it will run through the array and then increment it by 1. If I remove that, you notice instead of the powers of 2 like that, we get 1, 3, 7, 15, so on and so forth. So after having changed its value, when it comes around to execute the loop again, it still actually increments it by whatever the step is. And if I put a step of, let's put a step of 3 in there, you'll see even more wacky things happen here. So mutable, be very, very careful with these mutable controls. It is very easy to make a mistake, get stuck with infinite loops, that kind of things. Very rare that you want to do this. Only do this if you really can't come up with a better way of actually controlling your loop. Okay, so that was those kind of arithmetic type progressions. Let's look at initializing the array. So here's like the old school way of doing it, looping through. Notice here, I'm also got a new way of looping through the array. Instead of saying the indices of, I'm actually using whatever values we've assigned. So the multiples of 15 in this case, we'll do that, and we can see 3, 5, 15. And if I just change that to 7, just prove, you know, it's real and things are changing here, we get the multiples of 3 and 7. Okay. now let's look at the initializing, the newer syntax for initializing arrays. So this is what we would do. You could do in 18C. And like I say, if you know exactly what you want to initialize an array to, you could do something like this from 18C. But it's pretty unusual you know exactly which elements of the array you're looking for. Maybe it's a test script and you know you're trying to set things up very specifically, but generally in application code, I can't think of many situations where you would know this. So we can now put the loop in here like this. So we'll run these and we'll do that. You'll notice I've also introduced another little syntax here for the array controls. So we had indices of, get whatever the indexes were, values of, our values in the things. Hopefully they're fairly reasonably obvious what they do. But we also have this pairs of syntax. Now that's interesting. What's going on here? Well, what this is saying here is this, we've got two iterands as well. The first is whatever the index is, and the second is the corresponding value. So we're able to actually reference each of these directly. Can be a way to simplify the code. So you can see that these two things, two ways of initializing the array actually give the same output, or generate the same things in the same way. So a number of neat ways to make it easier to loop through arrays, generate or create arrays, generate them, that kind of thing. And finally, if, on these newer arrays, let's look at the using a cursor. So I've got my FizzBuzz cursor, generating them up, and we can put that in there and we'll get those values. So let's just change that. Let's do 4 and I don't know, 9 this time. Pick some numbers out and we can see there's only two things that are multiples of 4 and 9, less than 100. Well, multiples of both 4 and yeah. Okay, so a whole bunch of new syntax there to do that. Let's move on and look at that array controls and managing those. So I'll create a couple of tables here, and we're saying we can't have negative prices for our products. Seems like a reasonable rule, right? Now I'm doing a bit of a just a thing to create some errors, just taking the sign of the value and the cos. So sign and cos go between -1 and 1, so we'll get some errors here. And we've also got our save exceptions. So we need to capture that error. We're going to have a new exception for it. So this isn't an inbuilt one. We have to assign it to that. I'm going to initialize my array of products from 1 to 10 and try and insert them. And as I said, because the sign and the cos will return values less than 0, we are going to get some errors in both of these. So when processing that, we will loop through those using our new array constructors, qualified expressions, and get the value, the corresponding product that actually caused the problem. We'll do the same. This code for the invoices is basically the same. We just change the tables and variable names. Finally, we will combine those two order arrays together into one array. And because we're using the index here, taking the values, so the indices are the products that had the error, okay? And they are also the values that we are inserting here. So let's now run this. There we go. We can see a whole stack of errors. So product IDs 2, 3, 4, 5, 6, 7, 6, 8, 9, 10. They failed to insert to one table or another. We look at the order items. Yeah, okay, you see missing 4 here, 10, 4, whatever the ones, and up to 10, and invoice items, you know, missing 2, 3, 4, and then from 8 onwards. So that was the demo. I'm pretty sure it might have been a bit quick. A lot of you, looking at this go, ooh, amazing. How does this actually work? As Monica said, I will be sharing the slides. They will be available soon. I'll also send this script to her so she can share this with you as well, and you can play around with this too. If there's any last questions or comments, please put them in the Q&A window now. I'll just set while I say a few closing things. So we looked at using PL SQL to help manage our transaction control. We started with the problem where we've got an application sending lots of SQL statements to the database, and we had a lot of backwards and forwards from the application to the database. Big way to avoid this is to use PL SQL, combine everything in one call to the database. This is particularly beneficial when you've got a transaction which will run lots of different statements, okay? Particularly if you've got one that, things like creating orders, probably the classic example, because there's a whole bunch of tables you typically need to insert into. So by sending it all to the database in one call, we can eliminate or reduce network access and remove that component and speed things up. We had a good look at the new loop controls available in 21C. There is a whole stack of things, and actually, I still didn't quite cover all the things that were in this. We looked at things like, being able to skip over values, change what the increment is, repeated expressions. Perhaps most usefully and generally, certainly for me, is the new array controls. So you can actually use an array to control a loop. And then we looked at new constructors, array constructors specifically. So we can see how we can use loop-like syntax to initialize new arrays, not only for numeric values, but actually use essentially cursor for loops to initialize these arrays in one statement. Really helpful if you actually want to use a column from a query as the indices for that variable. If you want to try these things out and play around with 21C, two great ways. I think the best way is to actually sign up for our always free account. This gives you access to up to two Oracle autonomous databases. The demo I was just running now was on my always free autonomous database running on 21C. So, that's a great way to try things out. If you prefer to run, things locally, you've not got limited network access, say you're on a plane or something like that, you can also get Oracle Database 21C XE. It's the fully featured, fully free version of Oracle Database. Note it's limited to 2 CPU threads, 12 gigs of disk and 2 gigs of RAM. So great ways to try things out, play around and get up to speed with the new things in 21C. If you want to dive really deep into these new iterator controls as well, I've got a huge blog post which goes into these in a lot more details. I'm not seeing any other questions or comments come in, which either means I did a great job and you all understand it perfectly, or you're all so confused and baffled you don't even know where to begin with asking questions. I'll assume it's the first one, right? Because I can feel better about myself. But we're kind of just past the hour, so I think we'll wrap up. You can always reach out to me on Twitter and things like that if you want to stay in touch or ask questions or reach out and ask Tom. So all that's left to say is I really hope you enjoyed this. More importantly, I hope you learned something. I'm Chris Saxon and hope to see you again sometime soon. Cheerio.